Well, folks, here we are already in week 7. This week, you'll be reading the chapter on foundations and doing some of the associated materials. Before we get started in earnest with discussing Chapter 7, I just wanted to discuss a couple of other elements of the course. Several of you have submitted your CFI trainer certificate on fire dynamics from last week. Again, if you haven't completed that, please complete that at your earliest convenience. They will issue you a PDF certificate and just forward that certificate by email to me. My email address is listed in the course contact information, and that's the easiest way to get that to me. Additionally, we're supposed to start the National Construction Safety Team Technical Report Review in week 8. However, I've become aware of the fact that due to the current federal government shutdown, the NIST website is offline, and so you don't have access to any of those reports at this point. I'm not sure how long this is going to persist. It doesn't look like NIST is going to be putting their website back up until the government's back in service, and so we may have to make some adjustments to that assignment. But at this point, we're not in the driver's seat on that, so we will take it as it comes. For Chapter 6's materials, you'll basically read the text, and you will take the associated quiz on the text. And Chapter 6 deals with foundations. We don't in the fire service real frequently deal with foundations, but there are some good reasons to know some things about them. The thing that we would be likely to be called to in association with a foundation is probably a soil collapse during excavation. And so what I've done is I've created this link to some materials by Dr. Alan Scott from UW Stout up in Menominee. And these materials is a short section that just talks about how soils behave and hazards associated with excavation, hazards associated with trench collapse. What you got to remember about soil is soil works on friction. Soil is held together by friction, and there's a characteristic of soil we call the friction angle of the soil. So if you can imagine the soil coming off the end of a conveyor and piling up into a pile, the angles on the side of the pile are going to be dictated basically by how sticky the soil is. So if you had something like damp clay, that's pretty sticky. It'd have a very high friction angle, as opposed to something like silica sand, which is very slippery. It's going to have a low friction angle. Because friction is what makes soil stick together, anything that changes the friction between the soil particles can have devastating effects in terms of collapse. So common things would be things like water, right? And we see mudslides. Mudslides happen because the water basically provides a lubricant between the soil grains and reduces the internal friction. And a slope that perhaps had a friction angle like this with water mixed into the soil can no longer maintain that friction angle, and so it slides out to assume a lower friction angle that the soil is able to maintain. Another thing that can cause loss of friction between particles in soil is vibration. And so one of the things that we see commonly is that when excavation machines are used in close proximity to a trench or something like that, the vibration of the machine itself can cause the wall of the trench to slough and fall in. And this is why OSHA requires protection of workers who are in the trench. Other things would be things like passing traffic. One of the kind of hallmarks of the technical rescue discipline when they're doing trench collapse is that no heavy equipment get parked near the trench. We park all the fire engines and everything away from the area of the excavation because that vibration can cause a relative loss in friction between the particles of the soil. If you think about dump trucks, like your standard 10-yard construction dump truck, you may notice that when they're emptying the bed, you hear this kind of brrr sound, and that's they're running a shaker to induce some vibration into the soil to break down the friction and try and get the soil to slide cleanly out of the bed. Similar principle. So after you've completed the chapter, I would like you to just read through, it's a very short section, a few pages from Dr. Alan Scott about soil mechanics and the hazards associated with soil mechanics. In addition to the materials on soil mechanics, there is this optional module here, which is some pretty good science from the underwriters' laboratories. So you may be aware of the UL as an organization. The story is UL is a privately operated laboratory that provides certification for many engineered products. So many of your appliances, you'll find they have the UL stamp on the back. UL also provides approvals or laboratory testing for construction materials and techniques. And this link that's posted in Blackboard will take you to basically a webinar from UL where they're talking about some of the science and some of the scientific testing they do of floor structures. So the scenario that they're looking at is a fire in a basement impinging on the wood floor structure above of the grade level floor in a single family residence. And the materials are not required, but I think they do a good job of highlighting the hazards associated with working on the first floor, on the grade level floor of a residential structure when there's a fire in the basement. It wasn't Wisconsin's most recent firefighter fatality, but firefighter Arnie Wolf from the Green Bay Fire Department lost his life in a single-family structure fire where the fire was in the basement and basically burned away the floor structure under a thin veneer of concrete used in an in-floor radiant heat system. And this testing from UL kind of reveals how something like that can happen. So it's good stuff, and I would encourage you to look at it if you have the time. The last thing I'd like to address before I turn you loose on this week's materials is this video of a controlled demolition induced collapse. So last week we watched a video where they were attempting to do controlled demolition, but they failed to observe some of the basic fundamentals of structural engineering, and it didn't work out for them. This is a technique that's used in the U.S. It is actually a patented technique, and you'll see that it's a little bit better planned. So what you'll see here, this is likely a Class 2 building. So it's not hardened against fire, but its structure doesn't contribute at all to the fire load. And you can see that its primary construction is of reinforced concrete. Now, the type of collapse that they're attempting to induce here is a progressive or a successive collapse of floors below this falling mass. So essentially what the contractor has done in this case has they've severely weakened much of the structure, and then they're pulling out the last remaining structural supports, and this large mass above the floor where they're doing the work is going to fall and act as a hammer, basically successively crushing the floor structure of each floor as it falls. And of course the falling mass increases with each succeeding story. This method is very similar to the mechanism by which the World Trade Centers collapsed, in which a single floor lost its ability to resist the weight above it, and the materials above, once they were moving, produced a dynamic load that just simply was overwhelming for the structure of the building. And again, the intent here is a controlled collapse of this structure without using energetic materials, i.e. explosives. So we'll watch the video now. So you can see that what they're doing is they're just simply using heavy equipment with wire rope. And they've, again, severely weakened the structure on the floor where they're working. And now they're just working to dislodge this final load path. The difference between this and the one that we watched last week is that you'll recall that last week they had basically removed columns from only one side of the structure, which resulted in a moment that caused the structure to roll. Whereas this structure, they've removed materials from all sides, and the result being that the structure remains in rotational equilibrium, but it loses static equilibrium. It falls straight down and it crushes the floors below. And that'll conclude my comments for this week. As always, if there's anything I can do to assist your learning, please feel free to get in touch with me at the contacts listed in the course syllabus.